Hi, so let's discuss the Cannizzaro reaction. So first, let's learn about some of the properties. So this is a reaction with an aldehyde molecule. Aldehyde molecule having no alpha hydrogen undergoes disproportionation. Okay. So first, let's understand what is the meaning of this term, that no alpha hydrogen. So that means the carbonyl group C double bond O group, it should not have any carbon attached to it directly to which a hydrogen is bonded. That means the carbon directly attached to the carbonyl group should not have a hydrogen. Actually, the carbon directly bonded to the carbonyl group is known as the alpha carbon, and then so these are all alpha hydrogens. So an alpha hydrogen should not be present. That is, there should not be a carbon which is bonded to the carbonyl carbon which should have a hydrogen atom. For instance, if we take acetaldehyde, then we can write it like this. So here this CH3 carbon, this carbon is bonded to the carbonyl carbon, and this has three hydrogen atoms. So that means it has an alpha hydrogen atom. It has three alpha hydrogen atoms. But if we take benzaldehyde, so if we take benzaldehyde, then here there is no alpha hydrogen because the carbon over here, it does not have a hydrogen. The carbon in this particular carbon, it does not have a hydrogen, so obviously it does not have a alpha hydrogen, so it's not present. Similarly, formaldehyde, if we take, it does not have a alpha carbon only, so there is no point of a alpha hydrogen too. So benzaldehyde and formaldehyde, they will definitely give a Cannizzaro reaction, but acetaldehyde or any such aldehyde which has an alpha hydrogen, that means it has an alpha carbon containing a hydrogen atom, those will not give Cannizzaro reaction. Okay, and what is the meaning of the term disproportionation? So basically, what happens is this particular aldehyde molecule, which does not have an alpha hydrogen, this undergoes both oxidation and reduction simultaneously to form two different products. So when the same molecule is undergoing both oxidation and reduction, it is known as a disproportionation reaction. We have already learned about this in your redox reaction chapter in class 11. So basically, what happens is this aldehyde, when it is treated with a concentrated alkali, concentrated NaOH suppose, then the product is the same acid and an alcohol. But the thing is, this acid cannot form because sodium hydroxide is there. So sodium hydroxide will react with this acid to form the sodium salt of this acid, which is sodium carboxylate. So this is a reaction where an aldehyde molecule, when treated with a concentrated alkali, about 50% concentration, then it forms an acid and an alcohol simultaneously. Okay, so let's learn the mechanism of this reaction. So the mechanism. So this is your aldehyde molecule, right? And we have reverted OH minus. So the thing is, in this particular case, there is no acidic hydrogen to be abstracted. For example, in acetaldehyde, this hydrogen was definitely acidic. Why? Because when the OH minus would abstract this hydrogen, then the resultant conjugate base would be stabilized by resonance. But in case of formaldehyde, if this hydrogen is gone, then the negative charge will come on this carbon, which cannot be stabilized by resonance, right? Because this is not in conjugation. So in this case, there is no acidic hydrogen. So this base, it cannot abstract any acidic hydrogen. So instead, it will attack on the carbonyl carbon. That means if I take formaldehyde as an example, then this OH minus will attack on this carbonyl carbon. As a result of this, this bond will open up, and what we will get is this CO minus. We have an H, OH, and another H. Now, whenever there is an O minus over here and there is a lone pair of oxygen. So such a huge amount of negative charge can create repulsion. So when two such electronegative groups that are attached to the same carbon, a lot of repulsion is happening. So this bond will come back, and now what will happen is one of the hydrogens will move out, because if this OH moves out, then we will get the same product. That is, this only we will get. So the hydrogen has to move out. And if this bond comes back, then there must be positive charge on carbon. So this bond should break heterotically, in a heterotic manner. So this if this H goes out, then it will form an H minus, and the carbon will have a C plus. So what we get is an H minus plus COH, OH, right? Formic acid. Now this H minus, this is known as a hydride ion. Okay. So now what will happen is we have another aldehyde molecule, formaldehyde molecule. This H minus, which we got from that particular reaction, this will now attack on this carbonyl carbon. This bond will open up and we will get this product.